projects, it's about 70% of cases, the data is used only on 10-15% of its potential.
If you don't have a way or the proper tools to display or to make some valuable insights or reports, it really becomes like useless.
The device sees snapshot. The platforms see the history.
If you get on the vehicle and DTC code like probably it's already late, you should have done something like before the trouble code appeared.
4 to 8 weeks of warning before something breaks completely changes the economics of the maintenance. No emergencies, no downtime. Hello and welcome to Navixy Telematics Talk, the podcast where we talk about important topics in GPS technology, fleet management, and smart mobility with leading experts. My name is Sorokin. I am the product owner of the IoT Direction at Navixy, and today I want to take a closer look at Industry 4.0 transformation in European constructions and logistics. I am joined by Manuel Mendoza, Sales Director at Assistant Telematics. Manuel, nice to meet you.
Yeah, thank you very much, Roman, and thank you very much for the invitation. Always a pleasure to do some projects together. So yeah, as you mentioned, I'm the Sales Director at Assistant Telematics. We're a fairly new hardware manufacturer on the GPS tracking and telematics field, but we all come from, like a very good background, having worked for other manufacturing companies. Just so if someone is not yet familiar with our name, just know that we have a very experienced team behind. And yeah, thank you very much.
It's a pleasure to discuss such complex topics with the experts. So just moving ahead, I want to start that when I'm looking at Industry 4.0 transformation, I see it standing on the 4 key pillars. Each of them, from the one side, opens up huge opportunities, but each one also creates the real obstacles to the industry. So I want to start with the first one, and I think the most important one is a data gap in industry. The first pillar is what I call the white noise paradox. Over the last 10 years, we've built a great infrastructure. I mean, the industry in general. We have chip sensors, available connectivity, satellites. Hardware now produces a huge streams of data, to be honest. But from what I see on the real projects, it's about 70% of cases, the data is used only on 10-15% of its potential. This signal is there. And Manuel, do you agree with me about the statement that many of the projects not fully utilize the possible data?
Yeah, well, 100%. I joined this industry around like 12 years ago. Under my perspective, like it has not drastically changed. Like since then, there was like the Canvas solutions, the option to have data directly from the vehicles and have lots of parameters. Of course, like products were more expensive, like not everyone had access to such devices, but it existed already. And when I look forward, like to today, no, it's more calm, but I would not say in the last decade companies have taken that much advantage of this data, as you will say. Like still nowadays, a small proportion of the whole market is really using on a deep level all the information and all the like parameters that they can get from the vehicles and the platform. Of course, a big part of this, it's also related to the software. So of course, like in this case, on your side, like depending on what you have available, you can take advantage or make this information useful. But even I have seen using the same tools regarding the hardware devices and the software. With the same tools, companies offering like very different solutions, like some extremely simple, like basic tracking, and with the same software and devices, so the companies really taking advantage of the data that they have. But yeah, I agree that still just a small proportion of the market really uses all of those insights.
I agree with you. And from my perspective, the missing layer between the raw data which we receive from trackers, and the business decision is the software logic. Without it, all the data in the world just become a noise. That's from the one angle. From the another angle, not every device provides a consistent and full amount of data which could be utilized in the future. Do you think the same?
Yeah, of course. Even though like there's several players that can access like such type of information, there's not too many devices that can get, let's say, consistently and on a good level across, like especially when we speak about like mixed fleets, that you can get data from various types of vehicles with one single device. It's very common and like probably the norm in the market that you have fleets with light vehicles, heavy vehicles, machinery. Like you will not find really in the market one type of vehicle fleet, or at least it's not the most common situation. So yeah, not everyone has a proper device for this. So of course, if you get the chance to get one, it's ideal.
Yeah. So that was my second point under this big pillar, what I called overcoming the software limits, because people often blame the software when reports don't match reality. But the truth is, if software can only show its maximum when the hardware gives it enough data, and that the data is clean and complete. If the device loses 50% of the telemetry, no algorithm, no matter how clever, will give you the right picture. So the data completeness and data integrity are not a nice to have right now. It's must have, to be honest. That's the foundation. Without it, the platform fighting with one hand tied behind its back. But as much as possible, logic should be tied to the software. The reason is simple, because software is much more flexible. We can push an update, and tomorrow morning, the whole fleet works by the new rules which defined on the software level, without firmware update over air and such things. We just corrected it, and it works. Of course, I understand that not everything could be made on the software level. So this is the point where we can collaborate with hardware. So some points should be done on the hardware level, but everything, if it's possible, should be handled on the software level. What do you think?
Yeah, no, I actually fully agree. Like we hardware manufacturers, a lot of times we like to think that like we're the coolest part of the solution, but in the end we're just a piece on the puzzle. Of course, we're usually like the source of like getting this data, but this data is gonna be only as good as what you can show on the software. Like as you mentioned before, like you will just become like noise if you don't have anything to show or anything to do on the platform side. So like it happens sometimes also with different softwares that maybe, let's say we get with our Canvas device 80 parameters, but on the platform side you can have like reports or some useful information with like 5 of them, or maybe you don't even have the capability to show all of the parameters on the software side. So as much as we would like to tell that you get a lot of data, if you don't have a way or the proper tools to display or to make some valuable insights or reports with this information on the software side, it really becomes like useless, So yeah, the data is going to be as good as what you can display on the platform side. So yeah, that's why it is extremely important that there's this synergy between the software players and us, the hardware manufacturers, to I would say that to provide to the market with useful tools that also work to I would say like educate like what can you do with this data. I think another limitation sometimes is that you get a lot of parameters from the hardware, but no one has really shown to the market what's the value of such information. So not every service provider has a lot of resources or time to be experimenting on why a certain parameter is valuable, or what insightful information you can show to the end user with those things. So still, as we were mentioning before, in the last 10 years, still companies ask you for the odometer, speed, fuel level, and RPM. So when you can actually access tens, or even in some cases hundreds of parameters from one single vehicle.
Yes, I understand. It's quite hard to explain to the users what is the value of this data and how they can utilize this data to help the business grow. That's a really important obstacle which we together need to bypass. And from my perspective, the industry should move to the direction when we are not selling hardware or software. Yeah, we are selling a complete in-box solution, which includes hardware, software, some expertise advices. But here, speaking from the business perspective, we're looking at trade-off, because the mechanism which we described previously put more load on the system. Because the more data we receive, the more frequently we receive the data, the more load we have. Data should be ingested, normalized, filtered, and then we need to apply the rules to perform real-time actions. That's a serious engineering job, to be honest. And it's the place where exactly platform differs from a dashboard that looks like a platform from the real platform. And so to start a new topic, a new pillar, which is critical for me, the black box problem. And my position here is that firmware protocols should be opened, so each platform is able to communicate with IoT devices. And the most important for me, not only open, but also it should be stable. What I want to say, that open protocol, it's just a must-have tool to be able to integrate different hardware to different platforms to close the needed use cases for the users. But if the protocol changes from time to time, for example, one time in half of the year, no platform will be able to make constant changes to hundreds of the different protocols. And without this foundation, we cannot fully integrate that. So from your perspective, how do you think it should work? How often firmware updates should occur from the hardware manufacturer side?
In our case, from our perspective, usually the changes come with the new features or the new functionalities that the customers or the market requires. So it happens as often as we develop new things. That not necessarily the protocol needs to change. Usually we can just send a firmware update over the air. So technically this is not something too complicated. Even customers can handle on their own with a module that we supply to to every customer that uses our devices. And even for example, with this topic that we're mentioning about the data from the vehicles, if someone asks for supporting a new vehicle or a new machine that we don't have on our list, we can develop this fairly quickly and then just push an update over the air, like for us to support this new model or this new vehicle. So like in such cases, there is no critical changes on the protocol side, just like an update on the firmware, on the functionality. Of course, like we try to make our part, like on the protocol side, as easy as possible for the integration part. So for example, in our case, like all of our devices use the same protocol. So if you integrate the most advanced device, by default you will have integrated like all the device range. So usually there would not be major changes on the protocol side, and any issues, just a firmware update. And in such a case, an update on our configuration tool to support new features would be more than enough. But yeah, like really like firmware or new firmwares like depending on how many new functionalities like customer ask, or some things that internally we want to offer to the market. But yeah, of course, like here, it's also very important to have a close communication with the software companies to align that new functionalities are also supported on the software side.
Yeah, for me, this is also a question of trust between the hardware vendor and the platform. A vendor publishes a clear protocol and respects it over years. A vendor that hides everything and changes things could be considered as risky from the platform side. And from the customer's angle, and we need to look at it from the customer's angle. On the real side, the customer has a different trackers, zoo, how we call it, trackers from 5 different manufacturers, plus original equipment manufacturers from factories telematics, plus BLE tags, plus cameras, MDVRs, and different sensors. All of that is part of the ecosystem. Everything should be connected. And if protocol open and stable, we can guarantee that it will work and resolve customers' use cases. If not, there will always be a gap, and the customer will decide to work with a different platform or with a different manufacturer. Moving to the next pillar, it is technical synergy in high-stress environments. And here I want to start with the question that I think is often answered in the wrong way. Where should hardware filtering and where the software smoothing begin?
I mean, under our view, our role in the solution, is as you said, like to be able to get reliable, like stable data from the vehicles. I think one limitation that us like hardware manufacturers have a lot of times is that we don't get to have like too much visibility on what the service providers actually like do or intend to do with the device, with the information they get. So we need to supply as transparently as possible, like all the information that we can, like that our device becomes like the source or the tool, like to get all this information. And they like when you speak with the service providers that are like really like the people on the field doing the real work with the fleet owners, then you discover that there's companies that do very valuable work or very complex solutions that you didn't even think of, like as a hardware manufacturer. So I think really our main task is to ensure that you get good quality and stable data. And then it will be very important for you on the software side, and then later for the service provider on how they build the final solution for the fleet owners. Like to build like meaningful and insightful reports or alerts or solutions for the vehicles. So then like we prefer to have this approach to ensure, for example, in our particular case, we have one single canvas reading unit. So with the same device, you can support the reading of light vehicles, machinery, trucks, buses, and some like even specialized vehicles. And we're just constantly updating our support list. For example, now, well, when you mentioned about the quality of the data between like cheap devices and more like high-end units, for example, now we will already support the new generation of like if the data that it's essentially just like the new generation of campus reading with like with better like bandwidth and payload limitations that older systems like had. So we just ensured that we can supply the service providers the best data they can get and as much parameters as we can provide. So I think that's our main task, and what we need to ensure that we keep this level high.
Agree with your approach, because from my perspective, the device should be honest and reliable, and the logic should be on the platform level. The device should not think. The device should provide transparent and complete data. On our side, picture look like this: raw but clean data comes in, then we normalize it, then we apply algorithms, moving averages, adaptive filtering, anomaly detection, and then the customer rules and events run on top of it. That is the level where automation occurs. The big win is that it works in the same way on all the devices from the same manufacturer if the needed data comes in. Customer changes the device, maybe on the new model from the same provider, but the logic keeps the same. That's a resilient approach which scale in the future. Okay, I wanted to ask you how important, especially in heavy machinery, to have a protected devices. IP67 protection, or maybe even more. Is it important for the specific industries, or you might think that is something like overkill?
No, I think on the hardware level, this is probably like one of the first steps or one of the basic ones that we need to cover if we want to move on the specific segment of machinery. One approach that we had from the very beginning in Assistant Telematics was that we tried to standardize as much as possible like our different like hardware units. So in our case, all devices from the basic ones to the advanced ones, all are IP67. So like we prefer to have it that way because of the same situation we spoke before. We don't really know where that the customers will install them. So sometimes even some basic solutions are deployed on harsh conditions, like in various situations. Maybe not necessarily it's a construction environment, but for example, we have multiple customers in the Middle East or Africa where just the norm or the standard conditions is that around everything is extremely dusty because they're like very close to the desert or literally like in the middle of the desert. There's places like here in Europe that, for example, are extremely cold. So the device, in any case, needs to hold extreme temperatures, in some cases like very hot, in some cases very, very cold, like in very humid environments. So yeah, like from the beginning, we decided that every unit that we will launch will be at least like IP67, so it can be deployed on different conditions. I think for us as manufacturers, like doesn't represent like a huge change if from the beginning you design it like that. But yeah, like for sure, like on the machinery environment, or the construction environment, you speak about about like particular segments. 100%, like you need to have an IP67 device at the very least. So yeah, no, that part's important.
Okay, we're slowly moving forward to the second pillar, as I called it, sector-specific applications in constructions and logistics. And that's mostly about the real use cases when we're discussing about applying it to the Industry 4.0 transformation. I want to go through 4 scenarios that came up over and over again with our customer. First one is equipment. Second is video. Third is trailers and supply chain. That's the 4 the most used from my perspective. In each of them, the same principle apply: automation, ecosystem, data completeness. That's what we already discussed. And starting from the equipment, an excavator has a bucket and hydraulic breakers, a drill. From the engine view, the machine is just running, but according to what is actually happening, it is not working. Yeah, so the engine is running, but the machine is not working. And are you facing the same challenges from the business side, that it's quite an often case when engine is running and in fact it is not making the real value?
Yeah, no, all the time, like we get also like very similar requests on how to get like such type of insight, or how to monitor like certain like parameters or operation about the machinery. And then like here we're speaking about even not an extremely advanced like solution, but that becomes very, very valuable for the customers. So no, like this part, like for sure we'll get like very, very similar requests all the time, like especially when it's related to machinery. Probably this is one of the most important things, like just to have like proper monitoring on the use of the machines, like how many hours they are actually running, because like not only like those are working on an extremely harsh environment, but sometimes they're running a lot of time, like non-stop, so you need to very carefully monitor like what's happening with them and how many hours they're on, like to like to act accordingly, to properly maintain. So no, this is of course a very important point. Like that also we get the request like on the hardware side, like like how to monitor like such things sometimes.
Okay, I agree. And from our side, as a software provider, I want to highlight that it's quite important for such cases to make the needed level of automation to have the data from BLE tags, because once they provide us the enough data regarding basically everything which happens, we can make an automated rules to perform actions which is needed in a specific situation. For example, to block an engine, to make an alert in any messenger like WhatsApp, for example. Without the needed information, we cannot perform such actions. And if we have all the needed information, our customers is able to create the needed automation scenarios for them. And as far as I know, you are closely working with BLE tags in Assistant Telematics devices, right?
Yeah, I would say in general, BLE accessories. I think now the newer versions of the Bluetooth are much more stable than they were like years ago. Solutions have become like much more reliable, and then you can have a more flexible approach to solutions that before probably required complex installation, or not necessarily there was a very accessible accessory that you could source in the market. So now, for example, like BLE tags or BLE accessories in general give you a lot of flexibility. Even from our most basic devices. For instance, like the most basic device we have has just like two wires to connect directly to the vehicle's battery, but in any case it has Bluetooth. So even with a two-wire easy to install device, you can already install Bluetooth accessories. For example, what you mentioned about the NG blocking. So we can add a Bluetooth relay, or you can have a BLE key for the driver ID. You can have the BLE tags if you want to monitor also like movement or of certain like tools, certain parts of the machinery. Wireless solutions give really a flexibility that before we didn't have, and also for a more accessible price than it was before. So yeah, for sure. I think especially in those environments, like Bluetooth tags are a very friendly and flexible solution that you can approach the market with.
Sure, I completely agree with you. And once we have this solution, and once we have all the data, we can connect it to the ecosystem. For example, the current devices from any manufacturer could be connected to each other from our side. So if the device provides the functionality in the specific area, which is like the manufacturer focusing on the specific area, and the device is really good in this area, but some solutions require the combined functionality from one device and another device from different manufacturer. And the ecosystem should be able to combine this functionality, bind it to each other, and then making the system work together. So that's what we can do on our side. We can connect any of the device to the camera, to the device with the specific sensors, and make it work together on the one object. And we are okay. You can go ahead if you had something to add.
Yeah, no. I just wanted to comment that like especially with the Bluetooth accessories and sensors, since a lot of things are already like standardized, it's not very difficult to make it work, even if some accessory or some sensor is not directly integrated by us. The way we have it, for example, in our configurator tool, is that you can manually set like the values or parameters that you need to read for that particular Bluetooth accessory or Bluetooth sensor. So without us integrating, you can already scan it and receive data from it. Of course, like there are certain sensors that it's better that we make the integration because they provide specific parameters or on a specific way. So of course it's better if we make a full integration, but like you can just essentially set the device to scan what Bluetooth accessories or sensors are around, and manually you can indicate what these values or what the parameters that you want to read are. So like as we mentioned, like it has become much more flexible and easier to use, even in a lot of cases without the need to make an actual integration of third-party accessories.
That's a good point. But what I wanted to highlight that the transformations go further, and the more and more use cases and more sophisticated solutions appears on the market. So sometimes it could be valuable to integrate these solutions together. Okay, and to develop this topic, I want to move to our last pillar. Fourth one is predictive intelligence, maintenance, and digital twins. Starting from predictive maintenance. There is a lot of hype around it, so let me give my honest opinion. Predictive maintenance is not a magic, not an AI in the marketing sense. It's a basic mathematics, moving averages, trends, detections, statistical baselines. The reason it's becoming real now, it's not the Maslow smarter, but that we finally have enough good data over the long enough periods to apply it. So basically we generated data and we generated enough knowledge. So once again, it comes back to the data completeness and quality. Without those, no algorithms will give you a trustworthy trend. And looking at the real projects, I would say 70% of what we called predictive maintenance today is already real engineering. Only about 30% is still marketing. So it's not a hype, it's real things. The classic example is the oil temperature under the load. If for a specific machine, a specific operating mode, this oil temperature starts climbing slowly, week after weeks, that's a signal. No failure yet, but in 2 months, most likely, it will give a serious damage to the vehicle. And this is exactly where the platform plays the key role. The device sees a snapshot. The platforms see the history. Each machine has its own normal pattern. The algorithm tracks how the pattern changes over the time and signals where the change is statically meaningful. And the window we gain 4 to 8 weeks of warning before something breaks completely changes the economics of the maintenance. Share part ordered in advance, repair scheduled in planned window. No emergencies, no side downtime. And everything could be done automatically, just from the parameters which we received from the device. What do you think about this problem? How do you think, is the predictive maintenance is already a thing or just more about the hype?
Yeah, no, it's a thing. But I think still, like we mentioned on the first point, like probably not as many companies as they should are taking advantage of this information or this data that they have available, like from their hardware on the software side. But of course, like I consider that on this case, for example, like Navixy as a software developer and supplier probably has much more access to very valuable historical information, because you know, like we supply the hardware, so we don't necessarily have access to historical data of what's going on, so that we can make directly ourselves a proper study to later, you know, like make some estimations or take like proper statistics or make a very deep analysis, which, for example, in your case on the software side, you can check like all this historical data, you know, like to offer, as you said, like combining parameters, you know, like parameters from the vehicles that, for instance, like should not be happening together because you might damage a vehicle, or you know, like the hours of use, and then you correlate this with other parameters that you might have, and that you have seen historically on the platform, that there's an issue when some parameters are combined. Then you can offer like proper, you know, like predictive maintenance. Like we have with our device the capability to show like the DTC codes. But if you get on the vehicle a DTC code, like probably it's already late, like you should have done something like before the trouble code appeared. So that's probably the whole point. I mean, of course, it's good that you can get an alert on the software side um, if a trouble code appears, but ideally, vehicles should not get to the point where you have them like that. Precisely, we're speaking about predictive maintenance. Like we should be able to provide to the market the insights or the information, so to a fleet owner avoids that point where the vehicle already got the lights on the dashboard. So so yeah, but I think especially on this case, like software suppliers have a very valuable historical information that if there's some proper analysis, we can give something very good to the market.
Exactly. And from my perspective, I'm like think that automation should be on the next level. We should not just notify the client that something is broken. We just need to go and create a maintenance order, for example, in the CRM system of the customer. So basically, the system should work without manual actions. Everything should happen automatically. And of course, again, it's only possible if we receive enough data and it's a good quality. No anomalies, especially if we're talking about heavy machinery, hard conditions should affect. And when we use the proper data in a proper format, when we enrich this data with some external information, for example, it could be weather, it could be wind, and everything related to the conditions or specific business requirements. This way, we can build a real digital twin. And with these digital twins, the real maintenance starts. Having it not just a good-looking thing which we can only speak about. It's the real value once we are talking about any hard situations which always occurs. So I hope that businesses will move forward to the point where it is not nice to have thing, but must have thing to have a digital twin and have proper maintenance in the future. So to summarize what we discussed during the podcast, I just want to share my final thoughts. So Industry 4.0 transformation is already happening not on the software level, not on the hardware level, but on the level of collaboration between software and hardware, only working together to sell in-box solution. We can provide needed information and automated scenarios to the customers. If the hardware is not providing the enough amount of data, the software cannot compensate it by algorithms. If the hardware provides everything, but software is not able to work on the heavy load, not able to make automation algorithms and enrich the data, it is a lot of data which cannot be utilized as it was before during the last 10 years. So once every layer of this ecosystem covered, hardware, software, everything integrated to the one ecosystem, after this point, the real Industry 4.0 starts.
Yeah, I fully agree. And then, just let's say from our end, we were just trying to do things as easy as possible for the service provider with our hardware. So we have worked a lot on like simplifying like the process of like getting the data from the vehicles. One thing I would like to mention that I didn't mention before is that, for example, with our device, one thing we did is that you don't need to configure anything on the campus side when you connect to a vehicle. The device auto synchronizes, so it identifies automatically any vehicle. Doesn't matter if it's a light vehicle, machinery, or a truck. Once it's connected to the campus lines and you start the vehicle, it auto synchronizes and identifies already which vehicle it is and reads all the available data that it can get. So at least with that, we fully eliminate configuration mistakes that you can have. So we're taking very seriously this part of like simplifying as much as possible the process for the service provider on the hardware side. So just to ensure that you have as much data as possible on your software. But yeah, I think it's extremely important that we keep working together. So, like just for Navixy partners, like to be confident, like we have been working very closely on the last few months. And like the reason why we got this invitation to speak here is because actually we're growing quite a lot in Navixy. We're getting quite a good traction, and we're very happy working together. So we just invite everyone to have a look at our products, because particularly for this topic that we're speaking today, the feedback and also what Navixy has in is very positive. So yeah, like we invite everyone to check it, and I think we're making a very good team, like Navixy and Assistant Telematics.
Sure. To be honest, the reason of the invitation is because the data which we receive from your devices is has really high quality and consistency. So with that, we can work together. We can build our solutions and deliver this solution to the clients. So I can assume that we are the people who is moving Industry 4.0 forward.
Yeah, absolutely.
Okay, Manuel, thank you for your time. I think we can finish and to continue moving the industry together. Thank you.
Yeah, thank you everyone for joining, and yeah, we look forward to working with you. Thank you.
Thank you, everyone. See you in next podcast. Bye bye.